Hello students, following question is a 2 mark question from topic of indeterminacy, and it is somewhat similar to a question that we encountered before in this test also. Here it is asked that what is the degree of static indeterminacy and degree of kinematic indeterminacy for plane frame as shown in the figure. Also it is given that assume the negligible axial deformation. Now if we talk about static indeterminacy, and that to internal, it is given by 3 into number of cuts, and these cuts are number of cuts that can be put in the structure without making any of the portion independent of the remaining structure. Now in short it says that the number of loops that can be cut in a structure. Now if I have drawn this blue marks, these are the only two cuts that can be applied in this structure. Even if we apply any other cut, let us say I apply this cut, then I will be getting the portion that is marked with red color as a separate one. Okay, if I mark now cut here, like let's say this, then I will be getting this portion as independent one, that it will come out of the remaining structure, which is not acceptable as per definition of internal indeterminacy. So number of possible cuts are 2, and at each point we have 3 unknowns, fx, fy and m. So total internal indeterminacy is 3c, that is 3 into number of cuts, which comes out as 6. And if we talk about external indeterminacy, it is number of reactions, 3 acting at this point, 2 acting at this point and 1 acting at this point, 6. And number of equations of equilibrium are summation fx equal to 0, summation fy equal to 0, summation m equal to 0. Since it is a plane frame, that is 3. So degree of internal indeterminacy comes out as 6 plus 3, that is 9. And this includes both static external plus static internal. Alternatively, we have direct formula which says that degree of internal indeterminacy is given by 3m plus r minus 3j. Number of members are 11 if you count, and please don't forget this joint as well as this particular member, because this is also part of this structure and this joint is also having 3 unknowns. That's why don't forget this. So this is unknowns, I'm talking not unknowns, I'll say this joint will also have 3 degree of kinematic indeterminacy. That will deal in second part of this question. So advice is that don't ignore any of the joint. So if we talk about internal indeterminacy, 3 into m, number of members 11 plus r is 6, number of joints are 10, so it comes out as 9. But if we talk about kinematic indeterminacy, alternatively you can calculate this kinematic indeterminacy by counting that how many unknowns in term of deflections they are known to be determined, or we have a direct formula which says that kinematic indeterminacy is given by 3 into j, that is each joint will have 3 unknowns, that is deflection in x direction, deflection in y direction, if all the members are axially deformable. But here we have to neglect axial deformation and we'll put something to neglect that. So if all the members are axially deformable, this formula is a danger mark. Don't apply this formula and then go by the basics of structural analysis, that how many deflection unknowns. Deflection unknowns means deflection in x direction, deflection in y direction and rotations, that is theta. So but here since it is axially indeformable, it comes out as 3 into j minus number of reactions, which is 6, minus m, that is number of members, which comes out as 30, minus 17, which is equal to 13. So 9 and 13 are the correct answers. Students are advised to spend some time on this formula, that how this came into existence, why we are using 3j, why we are subtracting number of reactions, and then why we are subtracting the axially deformable members, the axially non-deformable members. The answer lies in the same thing that I explained here, that suppose all the members are axially deformable, then it is possible that this member will also go delta y, but now these members are not axially deformable, supports are not yielding. So to make these deformation is equal to 0, we take into account all the members that are having a negligible axial deformation. So correct choice for this particular question is option D, that is 9 as internal static indeterminacy and 13 as kinematic indeterminacy. Thank you.